Good day everyone, I am Sebastian from CMPL Semiconductor Group, advised by Dr. Estacio, and this is a synopsis of my thesis. Terahertz is a frequency unit of 10 to the 12 Hz located between the microwaves and the infrared in the electromagnetic spectrum. A possible terahertz radiation source is the photoconductive antenna biased by a voltage and pumped by a laser with photon energy greater than the bandgap of the material. To improve emission, increasing certain parameters is effective. However, this approach is restricted by the material's dielectric breakdown and risks PCA damage. Zinc oxide's properties such as high voltage breakdown and wide bandgap make it ideal for high power applications. We use the Drude-Lorentz model for carrier transport, which describes the behavior of charged carriers in the presence of the external electric field to model the PCA terahertz emission. To simulate the terahertz emission, we inputted the physical parameters of both zinc oxide and low temperature grown gallium arsenide. Then the functional definitions of the following equations were inserted. Solving these equations gives us the emitted terahertz radiation. The parametric study done in this thesis involves varying the laser power and voltage bias while keeping all variables constant. The results showed that the terahertz emission of both zinc oxide and low temperature grown gallium arsenide PCAs are comparable in magnitude, each expressed in the 100 volt per meter field intensity with peak amplitudes listed below. Furthermore, the parametric study findings indicate that increasing bias voltage and laser power values leads to an increase in terahertz emission. Increasing voltage or laser power potentially damages the PCA. Hence, this study also investigates the emission power before literature reported breakdowns. Findings indicate that low temperature grown gallium arsenide generates a stronger terahertz emission at low power conditions, whereas zinc oxide performs better at high power conditions due to its wide bandgap. It is also observed that increasing laser pump power or bias voltage has the same impact on the increasing terahertz amplitude. Thus, zinc oxide proves to be a more suitable substrate for high-power PCA applications.